and we are now recording this session. So I will hand over now to our host, Glenn Cooper.
Okay, well, welcome everybody, and thanks ever so much for joining us today. This is the second in a series of webinars from the National Cabba Biodiversity Group. And as Ali Morse introduced me, I'm Glenn Cooper and I work for Natural England. My main role is around coordinating lake restoration in Natural England, but I'm also have a role as the chair of the Cabba Biodiversity Group. And that group is formed of a small technical, if you like, expert group that represent a group of both national environmental NGOs and statutory agencies who have an interest in the biodiversity of water and wetlands. And one of the key aims of the group is to communicate advice and information to support catchment partnerships and other stakeholders for their work in delivering for nature recovery and biodiversity. And this webinar today is very much part of that aim. Just to note, this is one I said in a series of currently 4 webinars. We ran a webinar last week around the Cabba Biodiversity Hub, and there are 2 more planned for this autumn series. One coming up on lake restoration on Wednesday 9th of November, and also one on floodplain meadows as nature-based solutions in floodplain systems, and that's in December. And you'll be able to register for those if you haven't already from the Cabba newsletter. But there'll also be a link that's sent out after this this particular event. And also to note, as Ali said, this is being recorded, and this will go as part of that communication as well. So really, just to move on, my role here is just to kind of oversee proceedings. But I'm really pleased today to have Stuart Clark from the National Trust with us. He's a national specialist for freshwater catchment and estuaries. And he's going to be talking today for about 40 minutes or so on restoring natural function of river floodplain systems, stage 0 restoration and beyond. Stuart will give his presentation. If you've got questions, we're suggesting that you post them in the chat, and we'll, if Stuart hasn't answered them then in the course of the presentation, we can pick those up at the end in that way, unless there's something really pertinent or urgent at the time. But I think that's probably the best way, and then we'll follow those up at the end. So without further ado, I think just hand over to Stuart and let him begin.
Oh, thank you, Glenn. I'm just going to share my screen. Hopefully that's coming up for folks. Sorry, a bit of a delay going to slideshow. Has that come up?
Yeah,
Ali's nodding.
Worked.
Brilliant. Thank you very much. Well, thank you, everybody. Thanks for the opportunity to talk to you this morning. I'm going to try and give you a bit of an introduction, an overview to this thing which is tending to be called stage 0 river restoration, which you may well have heard about. And I just want to give you kind of a bit of background to what it is and where it's come from as an idea, and maybe by showing some examples of some work we've been doing in the National Trust, kind of make you think about where it might be applicable in work that you may be doing, and just kind of introduce the concept to what it's about. And I've put up a picture on my title slide, which is not a stage 0 restoration. It is a stretch of the River Stour. It's kind of the lower reaches of the Stour, and it's midsummer with abundant plant growth. And I just want you to kind of bear that picture in mind as we kind of go through this presentation, because I think this is kind of a bit of an illustration of what we are kind of talking about and working towards. And this is a system which is impacted, but through that kind of abundant plant growth is trying to perhaps reinstate some of the things that we're going to talk about. I've also put some names on my covering slide, which are just some of the people who've really kind of been very much instrumental in sort of driving some of these projects forward, particularly Colin Thorne and Ben Erdley, who works for the National Trust, but also Eleanor Miles of Atkins, who has provided me with some slides and has been working on a project which I will also refer to. So just an acknowledgement that they've helped out with this. So just to give you more of an idea about what I'm going to cover, just a really brief bit of context, the kind of usual depressing story before we move on to something more optimistic. Then a bit of an introduction to the kind of theory, if you like, and the concept of stage 0, or full floodplain reconnection, as it's often called. Talk you through some examples, and then perhaps take a step back and think about how we might achieve some of those results through different techniques and methods, and then finally sort of take another step out even further, and think about the sort of wider catchment and the wider kind of possibilities around restoration and looking after freshwater biodiversity. So that's the plan. So this is the sort of obligatory bit about freshwaters, and I think this is a really interesting development globally. And this comes from both a scientific paper on the left, which looks at the free-flowing rivers of the world, and what you just need to understand from this map is that blue are kind of unimpacted free-flowing rivers without dams and barriers upon them, and red are those which are impacted. And you can sort of see that the parts of the world where most of the population live, there are very few river basins where rivers are not impacted. And so, our kind of mark on freshwaters globally has been very significant, and you will all be very aware of that. What's interesting is these graphs on the right-hand side from WWF's Living Planet Index work. And in recent years, what WWF have done is started to break down the Living Planet Index into the 3 realms. And I think it's really interesting that we are now talking about 3 realms, and we're explicitly acknowledging freshwaters as one of the realms, whereas previously freshwaters were always wrapped up in terrestrial systems. And the really interesting thing I think about this is that overall, we've seen a decline of 68% in that Living Planet Index, which is about abundance of species since the 1970s, which of course is a story that's familiar to many of you, and a really desperate situation. But when we zoom in onto the freshwater component, and this is of course globally, the rate of decline and the overall decline is much greater. And we've had an 84% loss since 1970. So the pressure is really on freshwater systems, and we really do need to start doing something to reverse that trend. And that's very true from a UK context. And I've not today put any sort of figures about where we are in the UK, but I'm sure that many of you are familiar with the kind of state of our rivers and the fact that actually it's become very much part of the kind of public consciousness over the last 12 months. So we've been plugging away at kind of river restoration as one of the things that we need to do to deal with those pressures for a long time. And there are lots of great projects, there are lots of real successes, but when it comes to looking at the evidence of the impact upon biodiversity and wildlife of those projects, actually that evidence is rather elusive. And there's a quote here on this slide, which is kind of a bit of a review and an overview of successes of river restorations, which sort of says, gives that message that I've just sort of talked about, that the evidence is not really there. We're not seeing the expected outcomes. And then on the right hand side of this slide is a graphic which shows a really interesting study, which basically did what we always ask projects to do, and projects rarely have the resources to do adequately, but it's essentially to do some pre-restoration monitoring, to do some monitoring afterwards, and then repeat that at regular intervals afterwards. So in this case, 5 years later. And what you can see in the plot is that the change, so what we're looking at here is the effect size, so anything above 0 is a positive effect. For the stuff in channel, we really don't see any change during that 5-year period. And there's a slight increase, which is significant for riparian and ground beetles. So riparian plants and ground beetles, the stuff associated sort of with the riparian habitat is benefiting, but in-stream stuff is not necessarily benefiting. So this is kind of a real challenge, I think, for river restoration and habitat restoration in general, is that we kind of think we've got the theory, but for some reason we're not always picking up the success, and that may be because we're just not monitoring the right things. But it suggests that we kind of perhaps need to approach this in a slightly different way. And the National Trust, we've sort of been working a little bit across our land holding, which is very significant, and we have large areas of a number of catchments, but we've been sort of thinking about making landscapes wetter, so recognizing that not everything is just in the water and in the channel, and that's for both biodiversity but also for flood risk benefits. Making sure there's more clean water in the landscape, and that's often through small water bodies, but also trying to improve water quality. But then critically, I think also introducing more heterogeneity, more complexity into the landscape. And that's kind of become a bit of a kind of guiding principle, I suppose, for our work in the National Trust, but also for lots of organisations who are kind of involved in river restoration work. I think those of us kind of involved in this world are kind of increasingly recognising that there are huge benefits associated with sort of thinking about rivers in the wider kind of context. So rivers and their floodplains, but also thinking out to the catchment, which is something I'll return to at the end of this presentation. But in terms of ecosystem services, we can talk about flood and drought resilience, potentially capturing carbon in these systems, creating opportunities for recreation and access, and definitely delivering things for people who live upstream and downstream of those systems. But also, the potential for river systems to really play a role in nature's recovery, not just for freshwater biodiversity, but more widely, because these are the systems that are most dynamic in the landscape. They're the ones that change, the ones where flood and drought events can change the nature of habitats. So we get habitats being opened up and created and changed with time. And as we look into a future of climate change, that dynamism is going to become more and more important, because we're going to be unable to kind of keep things static and suitable for all the species that depend on them. So there's a huge opportunity here. And one way of making this kind of connection between the river and its floodplain and thinking more about a system is this idea of stage 0 river restoration, or full floodplain reconnection, as we might more user-friendly way of talking about it, perhaps. And I'm just going to talk a little bit about where this comes from before going into some of the examples around it. So this is kind of the genesis of the stage 0 kind of idea. And there's a lot of stuff in the geomorphological literature about stream evolution and how river channels change over time and with impact. And that's where stage 0 comes from. It's a stage in that stream evolution model, which we'll come to in a moment. But this work in 2008, which was published in journal Science by Walter and Merritt, is a really interesting kind of point of change, I suppose, and a paradigm shift, if you want to use that term, in how we think about river systems. And this is in the US. And what they discovered is that actually there was this legacy effect of thousands of mill structures that had been put into floodplains. So when the Europeans settled in the US, they had a huge impact on river systems and created the rivers that we see today. And prior to this work, the kind of assumption was that these sort of single channel rivers in the US were natural systems and were unimpacted, and the impact had come subsequently. But what this work kind of showed is that those river systems actually, and this is done by coring into the floodplain and looking at the ages of the sediments, that the original river systems were small multi-thread channels with extensive wetland systems. So rather than a single river channel, we have multiple very shallow channels spreading out through a wetland, either of short grazed pasture effectively, or of trees, so a wet woodland system with multiple channels. And because that impact on those rivers, and because the reason that they changed is because of these mill dams that had been constructed relatively recently in the US, and we have a record of it, there's good reason to suspect that in other temperate regions where a similar amount of modification had taken place would be very similar. So this is kind of prompted the kind of thinking that actually what we thought of as natural rivers are probably not natural rivers. And we've sort of been restoring rivers, I think, to an idealized endpoint for a very long time, which is a kind of meandering planform with all of the features associated with that, and lots of in-channel heterogeneity, but essentially a single channel. And that kind of model has been arguably used in lots of river systems, and yet we know, as this diagram shows, you know, actually depending on what your hydrology is like and what your substrate is like, you can get a whole series of river channel forms. And we kind of recognize that there are different river channel types, but we have kind of got locked into a world, particularly in temperate regions and particularly in the sort of lowland reaches, of assuming that there is one sort of dominant channel form. And in terms of this diagram, we've sort of often been trying to get rivers that look a little bit like number 20 down the bottom here into a form that's like number 21, or perhaps 18 and 14 that are directly above. So systems that are meandering through the river, through the floodplain, rather than being straight and deep and incised. And it's not uncommon actually for the river restoration community to talk about, re-wiggling rivers or putting the bends back in, and that's become quite a dominant kind of view of what river restoration is about putting the sinuosity back into systems. But we already know, as this diagram shows, that there is a multitude of channel forms depending on what the constraints are and what's going on. So if we kind of think about that in terms of these geomorphological theories and this kind of idea of stream development, we have typically viewed stage 1 of the stream evolution model as the kind of desirable, the reference state. And of course, what we're now saying is that stage 1 is already impacted. We've already seen some impact because we've gone from what we're now calling stage 0, which is this very shallow multi-thread system, into something which is degraded and is a single river channel. And what we've really been focusing on is moving from some of these degraded stages down here, so stages 3, 4, and 5, which arguably is a point where we start to see a bit of recovery. And we've been pushing them back and trying to get them into stage 1. And now what we're saying is that perhaps the reference state that we ought to be thinking about for some of these rivers is something slightly different, and it's this stage 0 idea. I find this diagram really useful actually in thinking about it. So this is a 3 sort of axes plot, which shows the degree of biotic interaction. So that's along the right hand side. The amount of the influence of geology across the bottom, and the amount of stream power down the side. And you can see on the right hand, the left hand diagram, sorry, how different channel forms fit within that pattern of, from low biotic interaction. So down in the bottom corner here, we've got often sort of bedrock channels, so high geological resistance, straightened, not much in the way of trees and aquatic vegetation influencing that system, but also high stream power. Over in the left-hand bottom corner, we've got the systems, so sort of alpine rivers, glacial systems, where we've got low erosion resistance. So we've got lots of perhaps fine material and gravel material, but very high stream power. So we end up with these very braided island systems. And then right up in the top, we have low stream power, but we have lots and lots of influence from vegetation. So trees and aquatic plants, shrubs in the river channel. And that's where we get this stage 0 type vegetation, where we have low stream power. So stage 0 is sitting right at the top of that triangle, where we've got low energy systems, but we've got very high influence from biology. And we can sort of see what happens when you do a stage 0 restoration. So this is some work from the States, which is where all of this kind of pioneering restoration work has happened. And at the very top, we can see an incised, channelized system, which has very sort of consistent flow through the channel, high scouring flows. Lots of material has been lost. So we're kind of down to large boulders and bedrock, so we're not seeing much erosion, but there's also not much opportunity for things to be growing within the channel. So we're right down in this bottom right-hand corner. Then some restoration work takes place, and they've reprofiled, they've filled in the channel, which is one of the steps that we often take in these stage 0 restorations, and they've distributed wood over the floodplain. But we haven't got the vegetation established yet. So we are still in an area where we're down at the bottom of the triangle, but we're down here. We've got high stream power still, and we've got very fine material, so we've got low erosion resistance. But then in the final and bottom photograph, you can see that the vegetation has now started to recover and started to play a role, and we've shifted our river system up towards the top, towards that stage 0 place. So now I'm going to just talk about some of the work we've been doing in the National Trust, and I'm going to use an example from our Riverlands programme, which is the Porlock Vale Streams project. Often we talk about it as Honeycutt, which is our National Trust property. So it's down here in Exmoor. And they've been doing some work there building on a previous natural flood management project. And they've been really focused on sort of natural processes. So we've got some work there going on stage 0, but also on beaver reintroduction, and also simply and just increasing the amount of woody vegetation within the catchment. And it's a place where we own about 95% of the River Aller catchment. So we've really got some control over what's going on, although lots of land is in our tenants kind of management, but we can work with our tenants and we can really do things at a landscape scale in that catchment. I'm going to show you some work that was done there on a small scale. So I mentioned Colin Thorne at the beginning of the programme, and Colin Thorne did a presentation about stage 0, probably the first time that it had really been talked about in the UK a few years ago at the River Restoration Conference. And Colin had been working in the US, and he and I got talking, and then he got talking to Ben Eardley. He is our project manager down in Exmoor, and Ben went out with some of the team from the Exmoor project to look at some of this work that had been happening in the northwest states of the US. And they went and they looked at these restoration projects, which were on a huge scale. And this is one of those projects, health and safety, sort of perhaps not as hot in northwest US as they were used to back at home in Honeycutt, but they were kind of blown away by the scale of this work and what was going on. And particularly when they went to some of the sites, just couldn't see how it might fit. But then I think on one of the last days that they were in the States, they saw something which appeared to be on a kind of similar scale. And when they came back, they started thinking about what they were seeing around the estate. So just keep this image in your mind, and I'll flick on to the next one. This is the kind of stream that they started thinking about. This is at Selworthy, and these streams, which previously they thought of as quite natural, perhaps overgrazed, but not the worst streams in England, certainly, but actually realizing that these were completely unnatural and really impacted, and wondering what they might be able to do with them. So these streams often pushed to the sides of fields. These are little more than ditches, really. They're headwater streams, but it felt like this was the kind of place where we might be able to start thinking about these things. And very much kind of straightened, pushed out of sight and kept out of the field, and really no interaction with the surrounding land. Water and land very much separate, and very much at odds with what those stage 0 projects in the US were trying to do when they were trying to reconnect the river with the floodplain. And in places, you know, you could barely see where the water was running, and it's running down the right hand side of this photograph under that hedge line. So they started to think about what would stage 0 look like on this really small scale. What would you do? And essentially what that means is filling these in, bringing the bed level back up, and allowing the water to find its way and create these new shallow anabranching or anastomosing channels across the floodplain. So they employed the approach that the folk in the US have been using. So this is from the US Forest Service. Paul Powers, who's really pushed forward this approach. And Paul Powers has developed a kind of tool, which is this geomorphic grade line, which sounds quite technical, but essentially all it does is it works out what's the natural valley bottom and what do you need to cut out and level, and what bits do you need to fill to kind of flatten it out again, and how do you kind of create a flat valley bottom that can then develop into one of these complex wetland systems where the water is more at the surface rather than flowing through in a single channel. So they applied this to the streams at Selworthy, and the project acquired the name Mudpool Meadow Stage 0. It was a non-main river site, so ordinary watercourse. Land drainage consent was obtained, and there was 2 weeks of work with a local contractor. So very small scale, basically just moving material around, filling in the channels, and just lowering some of the areas of the floodplain where previously dredged material had been dumped, and basically regraded the site and leveled it off, and then scattering lots of woody material across it. That material sort of came from across the estate, and it was all different shapes and sizes, and it was just kind of deposited randomly across the valley bottom or the floodplain. And the idea of that is to try and take some of the energy out of the water as it flows across while the site develops, but also to create some of that flow complexity. And now I'm going to try and show you as flyover of what that site looks like. So I'm hoping this is going to work for you. It's working on my screen. I'm hoping that's showing people. We can try and show it at the end if it isn't. But this is a flyover of the site just after the work had been done. I'm hoping this is working for folk.
Yeah, that's working fine, Stuart.
Thanks, Ali. It's quite difficult because it's working on my screen, but I can't see if it's obviously working for others, but great. Okay, so I'm hoping you managed to see that. Just to give you an idea of what it looked like immediately afterwards with all that material spread across the site. And we could show it again if people didn't manage to see it, or I can share it with you. And this is what the site looks like. This is a dry period after just about 6 months after the work was done, and you can see the recovery. And actually, you know, it looks nothing like a wetland at the moment. Really, it's a very dry feeling, and you wouldn't know there was any water flowing across the site. But actually, that's because what we're really seeing is what we were really hoping for. So this is a kind of pattern of water flow across the site, and you can see that what we've managed to do is turn this into a very diffuse, slow flowing kind of wetland system, which is depositing sediment, which is essentially very shallow even during times of high flow, and creating a wetland system rather than a single channel surrounded by effectively dry, short grazed grassland. And this is immediately afterwards, and this site is developing well subsequently. So that was kind of just a bit of a test, really, and the diggers are out on the ground at another site down at Honeycott at the moment, on the River Aller, so on the main river, which obviously has required some more difficult consents, including planning permission and a flood risk activity permit. But essentially looking at this stretch of the River Aller, which runs on the valley bottom, and is very much kind of hidden from view at the moment, running along this line of trees. And this section of river is incised, straightened, it's over deepened, the banks are poached, as you can see, and it's very very much an impacted river system. And even during high flows, it very rarely gets out into the floodplain. And if it does, then essentially it's a very large flood event rather than creating any kind of wetland habitat. And one of the rangers who's involved in the project was rather keen on trying to show what this might look like. And as I say, the work is happening as we speak, to regrade the site, but this is just a kind of an artist's impression, I suppose, and with a bit of artistic license about what that site might ultimately look like and what we're aiming for in that place, which is kind of inspired by what they saw in the US. So we're not the only people to be having a go at stage 0, and I've got a few slides now from the even load catchment. So this is on Blenheim Estates. This is work that's been led by Environment Agency, Joe Auld, and Eleanor Miles of Atkins and the team at Atkins. And essentially what they've done is they've done the same sort of thing. They've tried to reconnect an incised, impacted river channel with the floodplain, but they've taken a slightly different approach in that they haven't filled in the channel. They've created these sort of leaky dams, which are permeable and water does get through at the bottom. But so rather like some of the things you might see from a natural flood management perspective, but to encourage siltation of the channel, to slow the flows and raise that bed level, but also to push water out onto the floodplain. And they've lowered the banks in appropriate places to reconnect that floodplain. And that work was done last autumn, and this is a sort of sequence of drone flyovers, which just shows the impact of what's happening there. So you can sort of see in September 2021, before the work was done, you barely can see the river channel, but as time goes on, you can sort of see, particularly during the winter months where there is water on the floodplain, how they've moved from the channel into getting water across the floodplain and back in. And even during April, when it's dry, you can see the area of the floodplain which has been subject to that inundation, and that bottom of that floodplain is still being grazed, and it will take time to develop. And they also spread woody material in the same way that we did at Honeycott across the floodplain to try and encourage those sort of diverse flow pathways. And they used the geomorphic grade line tool that I talked about earlier on, so the work from the US, to model what they would get and the sorts of different habitats. So before doing the work, they created this image in the middle, which is the LiDAR output with that geomorphic grade line on, showing where they would expect inundation and flooding and water to sit, and those areas which would remain dry. And that's kind of informed the design of this and the low points that needed to be created along the riverbank. And essentially on a small scale here, we've got a river channel which is now better connected with its floodplain. And similarly to what we're doing now and moving on to a bigger site this autumn, that work in the even load is moving downstream onto a larger stretch of river to do something similar. So it just shows you that you can achieve the same results without necessarily filling in the whole channel. And it'll be interesting to see how this develops over time and what happens as sediment builds up behind those leaky dam structures in the channel. And there's quite a growing number of projects actually now which are sort of applying these principles and have characterized themselves as stage 0 or stage 0 like projects. So I've just identified a few, and apologies to anybody who's in Scotland. I work for the National Trust and now remit is England, Wales and Northern Ireland, and I couldn't easily find a good outline of the whole of the UK, so I've unfortunately just had to direct the outlawgie to the kind of north of my outline. But there's that project in Scotland, there's a small demonstration project in Lincoln that's been pushed forward by the Environment Agency. There's the Norfolk Rivers Trust work on the River Nar, which Charles Rangeley Wilson was kind of the designer of, and that's an image of it on the right hand side. There's a Welsh project in the Rydal catchment, which is a small scale restoration, which won a prize in the UK River Prize. And then there's our work down in Honeycutt as well. And I'm sure there are others which have tried to adopt similar principles. So why are we doing all of this? And maybe you've been wondering this as I've talked about it. Well, actually, these are some of the benefits that some of the monitoring that's gone on in the US has shown, but also just from a kind of geomorphological theory perspective, what we would get. So from a hydrological perspective, we're getting floodplain reconnection, we're storing floodwater, we're increasing the interaction between the groundwater and the surface water. We're having more time for surface water to seep into the ground and interact with groundwater, so giving us potentially more drought resilience and maintaining base flows rather than water being rushed down in a single channel and out of the system. From a morphological perspective, we've got more stable channels, we're getting sediment deposition and storage. And also we've got systems that are much better able to kind of adapt to changing flow conditions, vegetation moving in and retreating as conditions become drier or wetter, potentially, but also a system that is able to choose flow paths by itself in effect, if it had a will, but to create this sort of system. And then in terms of habitat quality, well, clearly, we're creating a wetland system that wasn't there before, but also, potentially through shading, through shallower water, we've got more stable temperatures. We have potential for nutrient cycling, particularly denitrification taking place, and also significant carbon storage within these systems. So we've been talking about stage 0 and lots of people talking about it, and I'm just going to try and talk about some of the things that I hear people asking and sort of preempt some questions really, and just want to sort of talk about what I've called some myths. But essentially there's perhaps a view that stage 0 is the new river restoration. It's what we should always be doing, and I think it's just worth bearing in mind that this is a reference point, which and it comes out of geomorphological theory. It might help us define a reference for restoration, but it isn't the only way to do restoration. And that's my kind of second point, is that this isn't the best way, this isn't the only way to restore your river. I think it's really important to recognize that it is only going to work in those reaches where stream power is low enough for us to get this kind of depositional. And one of the real challenges around stage 0 is, what do you do at the bottom end? How do you stop the system cutting a single channel and eroding a single channel back? And that's one of the real kind of technical challenges with this approach, is making sure that you don't end up with a single river channel cutting back. So we need to focus on those reaches that would naturally be depositional reaches, so reaches where water is naturally going to slow down and deposit sediment and settle out, so the valley bottom areas rather than anything else. And there are other ways to achieve some of those ambitions and create those habitats, and many of them have been employed right across the kind of river restoration kind of world. So using large wood, adding in gravel to bring the banks up, and removing constraints such as bank protection and levees. And you might be thinking, well, this is just simply connecting it with its river. And I think this is perhaps the controversial point, and it depends on how much of a purist you are. I'm going to make a pitch for, actually, if we're talking about stage 0, we really do need to be raising the valley bottom up, and we need to be using this cut and fill technique. That's not to say these other things are not really valuable and important, but I'm quite open to kind of an argument that all of these things are stage 0, and as long as we get the outcomes that we want, I don't think it really matters what we call it. And there are other ways of achieving some of these things. So I'm sort of going to move on from stage 0 a little bit. This is our Gold Drill Beck restoration project up in the Lake District, which some of you might have seen, which was completed the end of last year. And essentially here, we were unable to kind of reset the existing river channel, but we created a whole series of new channels which are higher and more connected with the floodplain, and replacing a channel which was deep, straightened, and running alongside the road, with a system which is much more kind of in tune and linked in with the floodplain, because the level of the bed is much higher. And this is kind of fairly typical of lots of really great restoration projects that are going on all over the UK now. The other way, and I'm sure many of you are familiar with the kind of opportunities this presents, but actually one of the other ways to get some of the habitat that we're talking about is through beavers. And I think people are recognizing that some of the things that we're achieving through stage 0 are some of the impacts that beavers have upon these systems as well, by raising the water table, by creating sort of slower flow and depositional areas, and creating this wetland habitat, and taking quite a lot of energy out of the river system, and of course also slowing flows, increasing the amount of water that goes back into the ground, reducing flood risk and helping with drought resilience. And we know that the kind of biodiversity impacts of that are significant, and there's some really interesting work which I've just shown one of the graphs from on the left-hand side here, which shows that actually when it comes to building wetlands, beavers are really much better than we are. And so maybe there's a kind of role here for beavers to do some of this work for us. And we know that in England, we're on the brink of a real change in what's going on around beavers, with licenses to release free living beavers into catchments very much on the horizon. And the other way, and this is kind of linking back to the even load project, is that we know that beavers are not kind of welcome everywhere. So, and they won't be, accepted in all catchments. But in the US, they've been using this idea of beaver dam analogs, and to kind of restore these incised streams. And this sequence of diagrams shows what happens with beaver dams and how they kind of restore these degraded rivers. So we move from A at the top, where beavers build dams that eventually get breached by high flows but still have an impact, and then over time, the continual kind of repair and building of those dams ends up with essentially restored river reach, which looks very much like what we're trying to achieve through stage 0. The beavers are very good at this, but you can replicate what beavers are doing, and this is very much what the approach on the even load is taking, through this kind of beaver dam analog idea, where you construct man-made dams to try and achieve the same thing. And it's possible to kind of get the same outcomes. And there's some really interesting work now in the US, which is kind of combining the two. So they've got some river systems which are essentially too degraded, too incised, and have too much power to be attractive for beavers to move in. And so what this diagram shows, moving from left to right, is essentially using these beaver dam analogs to kind of take some of the energy out, and to begin to create the conditions that makes it attractive for beavers to return, and beavers to start to create those systems and do that work themselves. So it's a combination of these approaches, and hopeful that we might start to see similar kind of combined approaches is developing in the UK as well in the forthcoming years. So just in conclusion, I think we're in a space where we are rethinking what natural river systems look like. And I show this diagram of the Danube, so some historical maps, and just quite how the Danube has been changed. But I think increasingly we're kind of recognizing that many of our lowland river systems probably were much more like this, like that early map of the Danube than we previously thought. And so we're kind of recognizing that river systems are much more complex than we thought, and they're much more connected across the landscape. So the kind of distinction between water and terrestrial habitat is much less distinct than we perhaps thought. They're highly connected up and downstream, and laterally across the floodplain as well. And that gives us lots of opportunities to buffer water quality and give us good water quality, give us resilience to flooding, give us resilience to drought. And it really rests on this idea that actually complex wetland systems, multiple river channels are probably more frequent than we thought, and perhaps the sort of thing that we should be aiming for where appropriate, and particularly in some of our valley bottoms. But I think in thinking about that, and I've talked a lot about river restoration today, but philosophically, I'm very much of the view that actually we need to be thinking about freshwater landscapes as a whole. And part of that message about river systems being more complex can be extended to the whole catchment. And we need to think about, the whole range of water bodies and catchments, the fact that species move between these systems. We need to be thinking about landscape scale as well as just the river channel. And we need to be thinking about those places where there's clean water, where there's refuge from high flows, and really placing our river restoration in a catchment context. So just to kind of draw some conclusions about stage 0 and that sort of wider piece, I think stage 0 is just another tool in the box, but it clearly has some significant benefits. I think it's important to remember it's not going to be applicable everywhere, but we should think of it alongside our other techniques that are trying to reinstate natural processes, because it's only by putting some of those natural processes back that we can make our river and floodplain systems kind of adaptable to what is coming with climate change. And I think beavers and sort of these beaver dam analogues have a role to play as well. And I think actually when we think about stage 0, we need to recognise that those river systems that we're restoring to when we do a stage 0 project are river systems that would have had beavers present. And these two things are intrinsically linked, and they probably work together. And so I'm hoping that we will start to see combinations of approaches which bring these things together to achieve these kind of really incredible outcomes that we can see when we do stage 0 restoration. And then that final point which I've just made, that actually we need to be thinking beyond the channel into the landscape. And as my final slide, I'm just going to show you what I think is quite an inspiring image from a US project. So the pre-project is shown up at the top, but you can sort of see what happens after this intervention of filling the channel and introducing lots of woody material. And I hope you'll agree it's kind of quite a dramatic change. And that's the sort of thing perhaps that we could start to see here. And that's me finished. So I'm happy to stop there and we can open up for questions.
Hi, Stuart. That's excellent. Thank you. Really great presentation. And as soon as you showed the movie, we started to get a massive stream of questions. So I'm going to try and pick through the sort of themes of those really. So I'll try and rattle some of these off. So going back to the trust project, simple question: was the woody material secured in place? That was one question. Or was it
so no, we didn't at Selworthy because essentially it's all on our land. There's no downstream flood risk. I think on the even load, some of the material has been pinned down. I think very much it depends on what the consents will say and what the risk is deemed to be and how big the material is.
Okay.
But the idea is that by taking some of the energy out, hopefully that woody material is not going to move anyway, because we've taken a lot of the energy out of the system. So, and we're putting large wood down, so hopefully it's not going to move.
Okay. Some various questions about grazing. There was a question about, was the land excluded from grazing and for how long? what percentage of land was lost to previous uses such as grazing, and what do the tenants think of any of that, losing that land to grazing? So questions around that.
Yeah, it's a really good question. So we've been having this debate around the River Aller, the main River Aller floodplain, and it gets us into a world around basic payment schemes and so on, and land coming out of agriculture. But we've been really clear, and the Even Load project shows this is very much the case, that actually this land is perfectly suitable for grazing. It can still remain agricultural land. It can actually provide quite lush because this is kind of wet, good soil moisture, so it can provide good grazing, but it might be different grazing and it might be extensive. There have been some concerns about increasing the incidence of things like liver fluke because of wet ground, but I think the message seems to be that with the right animals, so the animals that are hardy and are able to kind of deal with those conditions, you can actually create quite good agricultural land and good quality grazing in these wetland systems. You just have to acknowledge that it's different to kind of a traditional farm system, and our tenant on the Aller is very kind of comfortable with that and keen to work with us on that front. The other part of the question was, were stock excluded at Selworthy? Yes, and I think the grazing subsequently has been very, very light anyway. But there's this kind of period of recovery while the vegetation kind of gets established again, when you obviously wouldn't want animals in for risk of kind of soil compaction and damage to the ground. But vegetation tends to recover very quickly.
Brilliant, thanks. Just a quick addendum to that. No, had animals like pigs or sort of more, naturalistic grazing being introduced, or is that not happening yet?
Not yet, no.
Okay. Then following up with that was about kind of water quality issues. In that project, how have you reduced erosion risk around inlets and outlets at that stage where the stage sort of zero work was done? And do you have any issues with sediment flushes in the immediate aftermath of doing that restoration? So dealing with that kind of side of things.
So I think the Selworthy project, which is very much about headwaters, there's not much above the site bringing material in. So we think as well that we've reduced just by getting rid of the river channel, which was very poached, we've actually reduced a lot of the inputs anyway, but we're also trapping lots of that material. And we've got some videos and there's some data as well now, which sort of shows that actually what's coming out at the bottom end of that site is really good, in terms of water clarity and reduced nutrient levels. So there is an impact because materials being stored within the system, so there are water quality benefits. I think it is an issue where you might be further downstream, but we think actually by slowing the flow and spilling out across the floodplain, we're increasing the potential for nutrient cycling. I think the issue is denitrification, and so nitrate is not going to be a problem, but phosphorus, if we've still got large kind of phosphorus loads coming in at the top of the site, then there will be a point at which we'll have exhausted all of that capacity. So it's still really important to improve upstream water quality. I think the other point was about sediment plumes coming out of the bottom. We haven't seen that, but that has been a concern, particularly during construction phases, and it's like lots of river restoration projects. We are required to monitor that by the Environment Agency during the construction phase, because there is obviously a risk of mobilising quite a lot of fine material as you kind of move stuff around. And that's why a lot of this work is done at this time of year, actually before the winter, trying to take advantage of optimal conditions.
Okay, thank you. As a quick one on, did you have to take into account of protected species, and was there, how was that mitigated for, if you did?
I don't think we did at Selworthy, so I'm not sure. But I mean, I think the biggest concern actually that comes up around these things is the potential impact on fish and potential, fish passage through those reaches. But I think this is perhaps a reflection of the fact that we haven't really got much data. Some of the work in the US where they've done some monitoring has shown really significant increases in fish abundance and diversity following these kind of stage 0 projects, because you just create so much habitat, particularly for small fish. So these are, you know, really good for fish fry and fish recruitment, and you get a real benefit from that. But you know, maybe it's kind of a question about, you know, adult species and their ability to navigate these reaches. But the data from the US, appreciate very different systems, different fish species, shows a positive effect generally.
Yeah, and that was one of the questions, actually, impact on fish populations. Kind of linked to that was around monitoring. If you had kind of limited monitoring resources, what would you focus on, or what, you know, did the trust focus on in other examples? What are the key monitoring parameters you might focus on aside from maybe the fish?
Well, really good question. I mean, I think obviously flow is significant, but also I think one of the things that's really interesting about this is how much sediment is potentially being trapped. So any kind of indication of changes in turbidity is a really kind of interesting point around this. So are we storing sediment within the system, and particularly when it rains? So but also we've also been looking at nutrient levels and what's happening, so above and below. But I think those are the things that probably are worth focusing on. Is you know, are flows slowing down, and are we seeing a reduction in turbidity from top to the bottom of the sites, particularly during those rainfall events?
Yeah. I'm very conscious we've just clicked on to 11 o'clock, so we've got absolutely loads of questions that have come in. So I don't know whether people are prepared to stay. Stuart, are you okay to just cover a couple more? Just go
I'm
through
okay.
them, or?
Yeah, I'm okay if people want.
Okay. So this was right to your last point, actually, but it says there was a question about what considerations given to impacts lower downstream regarding summer low flows as a result of climate change, etc.
Because we're holding up water. Is that the kind of gist of that question, do you think?
I guess so, yeah. I think it might be, yeah.
So if that is the kind of meaning of the question, I think the point to remember here is that we're not necessarily, although we're creating a wetland and we are sort of slowing the flow, you know, we're effectively, it's the same amount of water going through the site, perhaps slowed down, but rather than being in a single channel, it's spread across more diffusely. So we're still getting water flowing through the site. I would argue from a drought perspective, then the downstream benefit is likely to be positive, because we've got this kind of wetland store that is releasing water more slowly than if it was just a single channel, which, you know, would be flowing through. So it hasn't been expressed as a concern, you know, that, you know, we might be reducing downstream flows. I would theoretically imagine that the benefit is likely to be positive.
Okay. Right. Let's see. Let's look. See if we've got any other questions. So they've been coming thick and fast, actually. So.
Oh, there's a lot, isn't there?
There are a lot, actually. I'm just wondering whether actually for some of these, whether we could follow them up afterwards. Perhaps just pick up on I think there's, again, just going back to the fish. Have schemes been done in fishery reaches from Fiona Bowles, done in fishery reaches yet? And we'll be maintaining lateral fish movements, as that will be key. Or that's kind of more of a statement, I guess, really. Okay. Just trying to read through these. Apologies, everyone. There's just an awful lot that's coming very, very quickly.
I know Joe, my colleague Joe Neville, has made the point that the pigs have been introduced at Selworthy now, so that's
right.
helpful, Joe.
Yeah. Going back to fishing, did you do any consultations with angling groups? That's probably quite a key one for some of these.
We haven't at Selworthy. I'm not sure what's happened on the NAR, actually, so I can't really answer, because that would be a kind of a key question. But you know, given on the NAR, Charles is very much a member of the angling community and an angler, so I suspect that means that he managed to get them on side. But I think, as I said before, you know, the point around angling is that it may not appear the reaches that are restored to this sort of stage 0 state might not sort of look typical angling reaches, but I think the evidence is that they could be really good for fish recruitment and overall, you know, have a significant benefit. for fisheries as well as for other species as well. And I think the important thing is that we're not going to end up with stage 0 reaches everywhere. First, because it's just not appropriate, as I was trying to say, that it's only for depositional reaches, but also because of other constraints. So the fear that we're going to end up with these kind of really shallow wetlands rather than our kind of traditional river channels, I think is rather unfounded.
Yeah. Okay. So very conscious of time. We're sort of 5 minutes over. I'm actually just gonna, if it's okay with people, because I think Jenny Wilden, who's been on the chat as well, has been answering quite a few of the questions actually, rather helpfully. Thank you, Jenny. There's an interesting one at the end actually, from Jack Helsby, which is, do you feel there's a version of stage 0 restoration that could be suitable within a catchment with higher industrial and infrastructure constraints? That's sorry, it's quite a tough question to ask, but just thinking about that, is about maybe that issue of scale. Could we do it in a more perhaps urbanized industrial environment? Are there risks around that?
I think that's a really good question, and I'm not sure I have the definitive answer, but I don't see why we couldn't. Essentially, it's provided the gradient is right, we could create these wetlands within industrial or within urban areas, but I think perhaps the challenge here is about communicating what a river looks like, because I think we all have this idealized view of what a river should look like, and I think stage 0 is quite a step away from that, and so there's probably a job to do if we want to kind of sell this to kind of communities about actually, because it will look very different to what they might be expecting. But I think there's no reason why we shouldn't be able to do that. I think the constraints are not that different. The constraints are often about what you do at the top and bottom end of it, and whether it's a suitable area. It's different to stage 0, but there are lots of good examples of beavers creating wetlands in urban areas in the US and in other parts of Europe. So if we can have beaver wetlands within urban areas, I don't see why we can't have stage 0 reaches.
Okay, yeah, no, it's a good point, isn't it? There may be those opportunities. Okay, I think there are a huge number of questions. I think we've tried to cover the sort of broad themes from people, and I said with others too. So I'm going to close it there, I think. Stuart, thank you so much for a really kind of engaging presentation. It's obviously, inspired a lot of interest from people, and there's been really good conversation on the chat. So yeah, lots of people really have enjoyed it. And the Q&A said thanks again to Jenny Wilden, who's put her address at the start for helping to kind of field some of the technical questions on this side of it as well while you've been speaking. And I think we'll leave it there. As I said, the recording will be circulated after this presentation to people. Stu, if there's anything on the chat that we didn't pick up that's specific, perhaps we can just have a quick look to see if there's anything to follow up. But otherwise, I would just say thank you very much for taking the time, everybody, for calling in. And again, thanks to Stuart for giving such an inspiring and interesting presentation. And hopefully people will be able to join us on the forthcoming webinars that, as I said, will be advertised when we send out the recording of this one. Okay. Thanks very much all, and enjoy the rest of your day. Thank you.